see some examples of tracing polar curves. The first example is trace r is equal to a into 1 plus cos theta. For tracing these curves, again we need to go through 4 points. The first point is symmetry. So in symmetry, there are 4 subpoints. The first is replace theta by minus theta. Equation remains as it is. Then curve is symmetric about initial line. Replace r by minus r. Then curve is symmetric about pole. Replace theta by minus theta and r by minus r simultaneously. If equation remains as it is, then curve is symmetric about theta is equal to pi by 2. Or replace theta by pi minus theta and equation remains as it is, then curve is symmetric about theta is equal to pi by 2. And last one is replace theta by pi by 2 minus theta, and if equation remains as it is, then curve is symmetric about theta is equal to pi by 2. Now here, if I replace theta by minus theta, then what will happen? R is equal to a into 1 plus cos of minus theta. But cos of minus theta is cos theta. So this equation will remain as it is. And therefore, this given curve is symmetric about initial line. Okay? So after replacing theta by minus theta, equation remains as it is. Therefore, given curve is symmetric about initial line. Now the second point is pole. For getting pole, we substitute r is equal to 0. For getting pole, we substitute r is equal to 0. When r is 0, it means a into 1 plus cos theta is equal to 0. This implies 1 plus cos theta is equal to 0 implies cos theta is equal to minus 1, and therefore value of theta is pi. So by putting r0, we got value of theta as a pi. It means curve passes through pole, and at pole theta is equal to pi is tangent. So theta is equal to pi, this is the equation of line, and this is the equation of tangent. So theta is equal to pi is tangent at pole. Third point is table of values. Third point is table of values. Now in table of values, what we do? We prepare a table which contains theta and r. Decide the range of theta. But how we decide range of theta? It depends upon the equation. If equation contains cos theta, so in the given equation, it contains cos theta. Cos theta have a maximum value 1 at theta is equal to 0 and minimum value minus 1 at theta is equal to pi. It means the range of theta for given equation is from 0 to pi. So now what I will do? In the row of theta, what I will do? I will select the values of theta from 0 and it is up to pi. So 0, next is pi by 4, next is pi by 2, here it is pi or 3 pi by 4, and then pi. When I substitute these values of theta in the given equation, I will get the values of r. When theta is 0, cos 0 is 1, 1 plus 1 it is 2. So value of r is 2a. When theta is 90 degree, this is 0. So value of r is a. When theta is pi, so 1 cos pi is minus 1. So value of r is 0. For remaining two values, we get the values of r as 1.7a and 0.29a. 1.7a and 0.29a. Okay. So we can calculate these values by using calculator. And these standard angles, I can calculate value of r mechanically. So now, after getting this table, what we have to do? We have to find tangents at some values values of theta where tangents are either parallel to x-axis or parallel to y-axis. So what we will do, at theta is equal to 0 and at theta is equal to pi by 2, we will calculate the tangent. Because at theta is equal to pi, already this is the tangent at pole. So only at these two theta we calculate the tangent. So for that, what we will do, we will consider psi is equal to theta plus phi, where phi can be calculated as tan phi is equal to r d theta by dr, and this can be written as tan phi is equal to r into 1 upon dr by dt. So tan phi is equal to, what is the value of r? It is a into 1 plus cos theta. This is the value of r into 1 upon dr by d theta. So derivative of this r with respect to theta, it is minus a sin theta. So phi can be written as phi is equal to tan inverse of 1 plus cos theta divided by minus sin theta. Isn't it? So we got value of phi, and therefore psi is equal to theta plus phi. So theta plus phi is tan inverse 1 plus cos theta divided by minus sin theta. Now we have to calculate psi at two values of theta, that is theta 0 and theta pi by 2. So first value, at theta is equal to 0, what is psi? So when theta is 0, this is 0, sin 0 is 0. So if denominator is 0, then this bracket is something upon 0, it is infinity, and tan inverse infinity is pi by 2. So psi is equal to pi by 2. It means at theta is equal to 0, the tangent is at 90 degree with initial line. Now next, at theta is equal to pi by 2, at theta is equal to pi by 2, what is the psi? So psi is equal to, now see, here pi by 2, I will write it as pi by 2, plus cos 90 0, sin 90 is 1, so 1 upon minus 1, it is minus 1, and tan inverse of minus 1, that we have to calculate. So if we calculate the value of psi, then psi comes out to be pi by 2. Okay, so this is pi by 2, this is, when we calculate the total angle, we will get psi equal to pi by 2. Okay, so at theta is equal to pi by 2, the angle is psi, it is pi by 2. So these are the tangents at some values of theta. Now after tangent, directly we have to trace the curve. Okay. Now the last point, it is shape of the curve. So while tracing the curve, the symmetry we will consider at the last. Pole while tracing or while plotting the point, we will consider it. So now we will point the plots which is given in the table. So first, I will draw the initial line and pole. So this is pole, this is the initial line. Now I will plot the points. When theta is 0, r is 2a. So theta is equal to 0 means this line, and on this line value of r is 2a. So it is, suppose I will consider this point as this, the point from pole, the distance of this point is 2a, and it is on the line theta is equal to j. The next point is on the line theta is equal to pi by 4, value of r is 1.78. So theta is equal to pi by 4, this is the line. On this line the value is 1.78. So maybe this distance from pole it is 1.78 because this is 2a. Next point is on the line theta is equal to pi by 2, r is a. So on the line theta is equal to pi by 2, is around point 3, so it is like this. So this distance, it is point 3 from pole. And for theta is equal to pi, value of r is 0. So for theta is equal to pi, value of r is 0 if this point. Okay. Now we will see the tangents. We have calculated tangents at these 2 points. At theta is equal to 0, tangent is 90 degree. It means on the line theta is equal to 0, this is the point. And at this point, tangent is size pi by 2. It means this line is tangent at this point. Means curve will take the shape like this. Okay, at this point. Next is at theta is equal to pi by 2. The value of psi is pi by 4. So psi is pi by 4 at theta is equal to pi by 2. Theta is equal to pi by 2. This line. On this line, this is the point. And at this point, psi is equal to pi by 4 is the tangent. So this line is tangent. So the shape of curve, it will be like this. So we will start from this, and then as this line is tangent, it will come like this, passing through these points. And again, at 4, this line is tangent, theta is equal to pi. If theta is equal to pi is a tangent to this curve, then curve will have shape like this, isn't it? Okay. So this is 50% of the curve. But as curve is symmetric about the initial line, whatever curve we have drawn above initial line, same it will be below initial line. So the shape, it will be like this. Okay. So this is the initial line and this is the shape of the given curve, and such curve